But is that so? Should we really believe in scientific realism as the best explanation of the success of science? Not so fast, the anti-realist would reply. Now, scientific anti-realism is a house with many mansions, and a prominent variety in modern philosophy of science is the variety known as constructive empiricism, which has been elaborated by the American philosopher Bas van Fraassen since the early 1980s. A distinctive aspect of constructive empiricism is that it agrees with scientific realism about the semantic aspect. Namely, a constructive empiricist would agree with the scientific realist that we should take the language of science at face value, that we should understand the main theoretical terms such as planet or electrons or whatever as referring to objects in the external world. But the constructive empiricist would disagree with the realist about the epistemic aspect. In other words, the constructive empiricist would claim that we don't need to believe theories to be true for them to be good. Now, the name constructive empiricism stresses that there is an important element of construction that goes on in scientific activity, especially in the way we build scientific models which are meant to be adequate to the phenomena. And the word empiricism emphasizes that this is ultimately an empiricist position in believing that our knowledge should be confined to the available experimental evidence, as opposed to going beyond the available evidence and claiming to discover truth about the unobservable. So what is the unobservable? And what does it mean that we construct models that are adequate to the phenomena, but they don't necessarily tell us the truth about the unobservables? Consider minerals. There are some observable phenomena that we can study about minerals. For example, their melting points, their hardness, how easily they may combine with each other. But there are other aspects which are, strictly speaking, unobservable to the human eye. For example, chemistry classifies gold as the metal with atomic number 79, and the atomic number is defined in terms of number of protons and electrons distinctive of that element. So, strictly speaking, whereas we can observe with our naked eye the property of melting point, hardness, and so forth, we can't observe with our naked eye the atomic number or the molecular composition of minerals. But we do construct models of them. Indeed, we do construct informative models, like these crystal models of minerals, for example, which nicely represent the molecular composition using balls of different colors arranged according to some geometric structure that is meant to be adequate to the phenomena. For example, is meant to represent how easily we can slice the minerals along some of these chemical bonds. Yet, the constructive empiricist would insist we shouldn't take models as providing the truth about the unobservable, namely about atoms, molecules, their chemical arrangements. Models must only be adequate to the observable phenomena. They are useful tools to get calculations done, but they don't deliver any truth about the unobservable entities. So constructive empiricism would insist that scientific theories need not to be true in order to be good. They only need to be empirically adequate. And a theory is empirically adequate if whatever the theory says about observable things and events in the world, past, present, and future, is true. In other words, the theory is empirically adequate if the theory saves the phenomena. In this way, empirical adequacy, rather than truth, becomes the aim of science. Now, this conclusion chimes in many ways with the old view of ancient Greek astronomy that the aim of science was to save the phenomena. But there are some important differences. For ancient Greek astronomy, the aim was to save the phenomena because Ptolemy and Simplicius and so forth thought that human knowledge cannot vie with divine knowledge. But after Galileo, that view could no longer be maintained. So for modern science, the reason why some anti-realists may want to insist that the aim is not truth but empirical adequacy has nothing to do with the distinction between human knowledge and divine knowledge, and all to do with the metaphysical commitment that theories bring along with them on one hand, and on the other hand with the idealized and abstract nature of the scientific models that we build. As far as the latter is concerned, in the past 30 years or so, an increasing literature in philosophy of science has stressed how abstraction and idealization enter into the construction of models, so that although the models are very useful and explanatory tools in everyday practice, they may not necessarily be true of states of affairs in the world, if not in a very idealized sense or in very idealized circumstances. For example, in this double helix stick and ball model of the DNA sequence, we need to abstract from the terribly complicated cellular environment in which DNA sequences can be found in nature. And we also need to idealize the atoms involved as perfectly spherical balls of different colors, as well as we need to idealize the direction of the helix spiral, right-handed or left-handed, to represent the different forms of the DNA molecules. So models can be very useful and informative and explanatory, even if we don't have to think of them as providing a perfectly true picture of the target system. As far as metaphysical commitment is concerned, the constructive empiricist would insist that she can do exactly the same good quality science as the scientific realist. In other words, one, again, doesn't need to believe that the theory is true to explain why we have such a successful science. One can just say that the success of our present theories is the result of a struggle for survival across centuries. So the best theories in mature science are the ones that have proved survival adaptive, are the ones that have proved to save the available evidence without necessarily being true. So in reply to the numerical argument, the constructive empiricist would insist that we can give an explanation, some sort of Darwinian explanation of why science is so successful by appealing to empirical adequacy rather than truth. Moreover, the constructive empiricist would insist that scientific realism is some sort of high-risk strategy when it comes to metaphysical commitment. What if the unobservable entities that we take to be true in the present science turn out to be like unobservable entities that people in the past believed to be true and they proved to be non-existent? What if in 100 years' time our electrons and neutrinos and protons and DNA turn out to be like the ether or the phlogiston or the caloric or all those other unobservable entities that people in the past believed and that are now just a remnant of a discarded past?